So in our last class, we did revision of what we've been doing from the beginning of the program. So that was Python fundamentals. And I said that's just like the half of what we planned for the class. From today on, we'll be dealing with Python for data analytics. We are starting with Numpy and Pandas. Am I still audible, please? Hello?
Yes,
Hello?
yes, we can hear you.
Okay, we'll be dealing with Pandas and Numpy. Pandas and Numpy, they are Python libraries. They are packages in Python. We've done something like that before when we import random, import math, import some other things. So to start with, Numpy, it simply means numeric Python. Import Pandas as import Numpy as NP. This is the line of code to import the Panda package, and this as NP is just like alias. If you don't put anything, if you just say import Numpy, anytime you need Numpy, you need to type it in full. Numpy dots anything. So to make it easy, you'll be using an alias NP, just like we are renaming it. Instead of calling it NumPy, we call it NP. So we use it for its numeric Python. We use it for numeric operations. So it is a Panda Python array. My array NP dots array. And we put in what we want. Array is just like a list of objects, of variables, of different elements. We must put it in a list first. We can now check our array. You can see this is array. We can check the type. You can see the data type. The data type is np dot array. So we have many dimensions for array. We have 1-dimensional array, 2-dimensional array, 3-dimensional array, and so on and so forth. And there are some attributes we call on array. We have some inbuilt arrays as well. For example, ones. np.ones. So this is telling us that we need, or let me start with just a 0-dimensional array, np.array. Then I put just a number, let's say 67. We can see that array is 67. Then we can check the dimension, n-dim. Let me name it 0. And I want to check the dimension dot. (n-dim). We can see the dimension is 0 because I have just a single value in it. Then we can create a 1-dimensional array. 1 equals to np.array. Then for 1-dimensional array, we put in a list of values. SS 34, 6, then 23. We all know we can remember this. We use the square bracket. We use it for lists. These square brackets, the opening and closing bracket. So I put the list in an array. I want to take the dimension for my 1.ndim. We can see that that's a 1-dimensional array. So by default, a 1-dimensional array, each element of 1-dimensional array will be a 0 will be a 0-dimensional array. For example, this 34 on its own is 0 dimension. This 56 on its own is 0 dimension. The 23 on its own is 0 dimension. But everything combined is 1-dimensional array because you cannot differentiate between row and column here. So this in mathematics, for the people that like mathematics, it's called scalar. Then we have 2-dimensional array. And for 2-dimensional array, it's just like a nested list. Like you have a list, then you have another list inside of it. Then this is my first. The first one I created. That's the parent list. Then inside it, I have my first list, and I call that 245, 67. Then I have another list inside 6, 78, then 12. So I can check the dimension. 2.ndim. Ndim simply means number of dimension.
Excuse me, please. I have a question.
I can hear you.
Please, there's something I want to ask you regarding this parenthesis you are using before the second
before the list.
Before the list, because
okay.
I think this thing is not working for. It's not working for what's it called? It's not working for the what is this other software we are using now? Jupyter Notebook.
Or what? Collab. Jupyter Notebook.
It's not working for Jupyter Notebook. I tried it this evening, but
no, it works same way for both Collab and Jupyter Notebook. The same way. Just this array is like a function. It's like an inbuilt function.
No, I'm not talking about array. Do you understand? What I'm trying to say.
You are talking about the parentheses we have in front of it.
Yes.
That's what I'm trying to explain. This is like the array from this place to this place, like a function. Whereby, even if you are not going to have any parameter in your function, the parenthesis is compulsory. You must put it there. And it works for Jupyter Notebook as well, the same way.
Okay, no problem. Maybe after the class, I will still.
Don't worry, after the class, you can try to share your screen. So those are the different dimensions we have in how to check how to declare an array, then how to check the dimension of the array. Then you can access the element of an array, for example. Okay, let me talk about the inbuilt array first. We have some inbuilt array. The first one is this np.ones. Let's say we want just two of them. Let's say 4. np.1 is just an array of ones. 1, 2, 3, 4. We have 4 ones. Then we can make it 2 dimensions. Inside it, we put another parenthesis. Then 4 by, let's say we need an array 4 by 2. 4 by 2 means 4 rows and 2 columns. You can see that everything 1. Another thing, we can also have zeros. Those are the 2 built-in arrays we have in Python. Instead of ones, we have zeros. I'm not sure this 0 is there. Okay. np.zeros. Then we need, let's say 3 by 3, 3 rows, 3 columns. You can see it. Everything made up of 0, 0, 0 everywhere. So there is a way we can access array starting from a single dimension array. R equals to np.array. Then we have a list of array in it, 45, 3, 2. And let's say we want to access. Can anyone tell me how to access this second element of the array? Any idea?
1.
1, okay. Let's try it. So that's it, we have 2. Just like normal indexing. Then to access the third element, we just put 2. This is out of range because our array is not up to 3. We have 0, 1, 2. We can slice our array as well by array. np.arrange. This should be an array of number from 1 to 10. Then we should be able to reshape it. np.arrange. Then we have 1 to 10. Should it be colon instead? I don't think so. Should be comma. So we have 1, 3, 5, and 6. Make use of range. I'm not sure. Let's just create our 3 by 3 array. So we need three rows, 2 columns. For the first one, 34, 6, 7. Then for the second one, 89. It will be in a list as well. 89, 9. Then 12. Let's check what we have in the array. Oh, I need np.array. So this is it. We have 2 rows, row 1, row 2. Then we have 2 columns, three columns, 1, 2, 3. So one thing we can do, we can reshape our array. Instead of having 2 rows, 3 columns, we can have 3 rows, 2 columns. arr.reshape. And 3 by 2. We see this now. Instead of having 2 rows, 3 columns, here we have 3 rows. This is row 1, row 2, row 3. Then we have 2 columns. This is the first column, then the second column from here to this place. So we can access elements from the array right now.
It's so fast.
It's fast. So let's say we want to access this 56 array, then square bracket. Then we know that this is the first row, second row, third row. What we need is in the first row, then second column. That will be, first row will be 0, then comma. The second column will be what? 1. Let's check this. That's 56. We have our 56. Let's say we need just this, just all the elements in the first column. That's from 34, 7, and 9. That's what we do. By the first number we put, it denotes the row. So we need 0. Then by default, if you put comma and you don't indicate the column you want, by default it will take all the columns. Let's see this. I see it now. We have 34, 56, and 7. That's not what we need. We need all these rows. Oh, the problem is I've not renamed this array. This is just like I just check it, but I've not changed the name. So I need to rename it. I need to rename. I need to store the new value, the new change I've done. I need to put it in a new variable. So I need 37, 34, 7, and 9. If I don't put comma by default, it will take everything here. It will take the first row, which is 0, then all the columns.
If you spoil this laptop.
Really?
You can see this. This means that the array 0, it means the first row. This is the first row, 34, 56. If I don't put anything in the column section, it gives me all the column. If I need all the rows, what I need to do is, this is all the row. If I need all the columns, I will leave the row empty. Then I'll put the column I need. Let's say if I put 0 as my column, that means I need this 34, 7, and 9. Then I need to put this as well. 34. This is first row and first column. Then all the rows, the first row, the 2 columns in the first row. Then I need just the first column. To get the first column, the column is here. That will be 0. I can't leave this empty. Let's do it with the first one first. Then 1. This is second row. Then first column in the second row, which is this 7. Okay, we have 7. ARR. Then let's say I need this 7 and 49. 7 is on the second row. I need all the second rows, everything in the second row. This 7 and 9. That will be 1. You can see that. Then I need everything in the last row. That will be 2. Let's say I need from 7 to 12, 7, 89, 9, and 12. That's slicing. I want to slice from this to this point. This is first row, second row. That will be 1, and the column. So I use this to denote that I need all the elements in the second column, 82, 7, and 89. But what I need is actually from this 7 till 12. And 89. Then what if I just leave it that way? Okay, this is from row 1 to the end of the array. That's why we have 7, 89, then 9 and 12. That's how to slice an array. If you need a particular element from the array, you can access this 34 alone, you can access 34, 36, you can access from here to the 4th element, then you can access everything together in the array. Let me see what other things we have. Slicing operation. Then you can perform different operations on your array. You can say array. Let's check what we have in our array. Then you can say array multiply by 2. By this, it's element-wise multiplication. It will multiply each of the elements by 2. You can see that 34 times 2, 56 times 2, 89 times 2, then 12 times 2, 24. We can do addition as well, plus 10. So you have everything plus 10. Twelve plus 10, 24, 34 plus 10, 44, 17 plus 10, 44. Another thing we can do, aggregate function. Array dot max. You can check the maximum value we have in our array. You can see that it is 89.
I'm sorry, please could you slow down a bit? I'm actually lost now.
Okay, the last thing I did here is operations, performing different operations on array. We have the multiplication operation, we have the addition operation here. You can do subtraction, division as well. You can do a lot of operations on it. Then the next one is aggregate function. Aggregate function simply means like aggregating the different values you have in your array. For example, this max function, it gives us the maximum value we have in the array. As we can see here, the maximum value we have here is 89, right? So that's 89, array.max. Then we can also check the minimum value, array.min. So that's the minimum value we have. Another thing you can do is to, by default, you can try to check the index. Oh, not index, axis. We have X and Y axis, just like the row and the column. You can change the axis to 1 or 0. By default, it is 0. You can change it to 1. Axis equals to 1. What if your axis equals to 0? So you have 34 and 89. This is telling us that, okay, the maximum value, in which row do we have the maximum value? This is 34, 89. It is telling us that the maximum value is on the second row. Then let's check the column. To check the column, we change the axis to 1. You can see this is the column, 56, 89, 12. So that's the different kind of operations we can perform on array. Let me try to go over it again. So you import numpy as np. The np is just like alias, like you give it another name. Then you start with np.array. This array keyword is very important. Then the parentheses, then you put in the list of what you want. If you are starting with a list, that is a one-dimensional array, because it's a scalar, we have 1, 3, 5, 6. If you are not starting with a list, you just put it straight inside. Let's say 45. Like this, we have a 0-dimensional array. So you can, if you check the data type, you see np.array. Then we have 0. This is what I just said, 67, no square bracket, no list. And we check the dimension is 0. Then we have np.arrays. We have, this is 1 dimension. Then 2 dimensions, like an array inside another array. That's it. And there are some built-in arrays, np.ones, np.zeros. Those are the 2 inbuilt arrays we have in Python. Then we have this as well. Then you can reshape. For example, this is by default, this is 2 rows by 3 columns. You can reshape it to 3 rows, 2 columns. What anything you enter first will be the number of rows you are going to get. Then the second element in the parentheses will be the number of columns. So when we reshaped this, we have these 3 rows, 1, 2, 3. Then we have the 2 columns. You have the 2 columns here. Then you can access each value, each element in the array. For example, you need this 1 0. 1 0 means the first row, then the 0 column, which is 7. Then this one, it means you need all elements in the first row. Then this one, you need all elements in the second row. And this one, starting from the first row, the one is denoting second row. Starting from the second row till the end, you want everything. Then this one too, this is for column. Then we have operations. You can multiply, you can add, then you can perform aggregate function. Max, you find the maximum value in your array. Min, the minimum value in your array. Then you can check the axis where you have the row the maximum value belongs to. Then the column the maximum value belongs to as well. Then another thing you can do min as well. Array.min. Not possible. Let's check. Okay, we have the mean value as well. So one last thing, the application of like someone will be like, what's the essence of all this? One of the application of this NumPy is MAE. MAE it means mean absolute error. It is being used in machine learning to measure it's a matrix used for regression analysis. This is MAE. Mean absolute error. Oh, someone said I'm fast. Too fast. This is the formula for MAE, maximum mean absolute error. This is the formula for mean absolute error. For example, let's say we make prediction. We predict the score of a student. I call it predict. Then the predict is np.array. Let's say the score of the student is 23, 45 in English, 67 in biology, then 78 in geography. Then I have the correct value, which is the true value. Then it depends on how close. It depends on how close my values are to the true value. For example, the model predict that the student scores 23, whereas the actual score is 20. Then for the 45, let's say the actual score is 47. Then for the 67, let's say the actual score is 70. You can see that. Then for the 78, let's say the actual score is 82. So we need to apply this formula to get the mean absolute error. So what we do is 1 divided by n. N is number of our observation, which is 1, 2, 3, 4, divided by 4. Then multiply by np.sum. Sum is an inbuilt function in Python. We created the function. We defined the function in the last class. It's something we can define on our own. So np.sum, then np.square. np.square is just like square root, like math.square we did the other time. This np.square, it does the same thing. Then we have prediction minus our actual value, which is the true value. One, 2, 3. Why do I have np.square? Why do I have the red line? Variable true, ND array, unknown, bread. Oh, I don't know if I've np.square breed minus true. Let me run it and see what the error is. Okay, you can see the sklearn. I want to try the inbuilt MA from sklearn. Don't worry if you don't understand this. You don't need to know it now. That's metrics. Imports mean absolute error. Absolute error, then put in my red, then my true value. Okay, red and true value. Okay, I should have the true before the prediction, the true value before the prediction. It's still the same thing. Let me try to change this to true. Right. .5, what's wrong? Let me check if I'm mixing up the formula.
I think something is wrong with the rating formula.
You said what? Hello?
No, I said I think something is wrong with the rating formula.
With the
Like the 1 over n multiplied by np. So
1 over n.
yeah, I think something is wrong because probably from what you checked just now.
Okay.
I think it was like the difference between the mean.
Okay, instead of the true minus breed. I don't get your point.
No, I was thinking like probably there is an error in the rating formula. I'm not sure, but let me just try and search as well.
NP dot, I did this few days ago. NP
I
dot
think,
square.
okay, from the first formula is spread minus true, and yours now is true minus spread. Is there something different there?
I did, that's what I did initially. I just changed it now. Spread minus true. I have the answer actually. I have 9.5, but I'm expecting something like 3.0.
Does the spacing matter?
It shouldn't matter. It doesn't matter. Yeah.
Okay.
Don't worry, I will get back to us on that.
Okay.
So that's one of the application of one of the applications of the NumPy. They use it to calculate the mean absolute error. Mean absolute error is to check how your model how it performs on the performance of your model on the prediction, the predicted value compared to the actual values. Is my screen still visible?
Yes.
You can see my screen.
Yes, we can.
Yes.
Okay. So Pandas is built upon NumPy. Once we have Pandas, we don't really need NumPy, but there are some cases, for example, like the mean absolute error, you need to make use of NumPy and some other cases like that. But Pandas is majorly used for data frame manipulation. It's a two-dimensional data structure. Like that means it's structured in row and columns, like the exact tables, all the different tables where you have different rows with different columns. So those one, they are very good for Pandas manipulation. So we'll continue with the Pandas tomorrow, and we start from this mean absolute error. So let's talk about the assignments we have. Okay, this is how I did my own. You import random, then I name the variable random number equals to random.random integer. Then we need a number between 1 and 100. Then I set my, like, this is just the number of attempts. I set it initially to 0. Then my guess will be, anything I entered will be converted into an integer. Welcome to the guess number game. You need to guess the random number generated between 1 and 100. Then you keep trying until you get the number correctly. So what is your guess? Once you enter your first guess, this might be the number of attempts, which is 0, which was 0 initially, it will be plus 1. So from here now, 0 plus 1, it will be 1. That's the first attempt. Then the reason why I use this while statement is because we know, for example, if you use a while loop, while true, the code will keep running until there's a condition to stop it. So that's the main reason why I use a why loop here. So why guess is not equals to random number, which means what I guess is different from the random number. Then under it we have some other conditions. The first condition is if guess is lesser than the random number. If guess is less than random number, then it will ask for the guess again. What your guess is, it will first tell the user that your guess is lesser than the random number. Try again. Then once you input something at that point, the t initially, which was 1, it will be t plus 1, which it means numbers of attempts. Then from 1 year it will be 2. If this one doesn't happen, this line, then else random, try again. If either of these two happens, either this or this, their number of attempts will be plus 1. The two of them cannot happen at the same time. It's not possible. It's either this if or the else. Either way, the attempts will be plus 1. Either this, either this. Then else, this else is just to close the while statement. It will keep asking you for a number until you get the correct number. When you get the correct number, that's when you have the else. Else print correct. You guessed right after t attempts. T can be the number of attempts you make, let's say 50, 100. So I will run the code now. I actually seen a lot of like fantastic solutions from people. I have some that are not as long as my own, that some are very short, and I have some longer ones. Welcome to the guess number game. You need to guess the random number, then between 100, you keep trying until you get the number correctly. Who is interested in playing the game for us? That will guess for us. Hello? Can you still see my screen?
Yes, I can.
Can you see this particular guess number screen?
Yes.
Okay, who is interested in playing it for us?
15.
15, okay. Your guess is lesser than the random number. Try again. So you try again with a bigger value, bigger than 15.
20.
20. It's lesser.
56.
You said?
28.
28. Lesser. Maybe you guess 60 times before we get the correct one.
99.
Lesser. 79 is lesser than the random number.
1 million.
88. 88.
88. It's
1 million.
greater. It's greater.
275.
So between 1 and 100.
Oh.
99.
99. Since it is greater, 99 is greater than the number, so we can just go back. Let's say 78. Lesser than 83.
84.
Correct. So the random number is 83. Who can play the game 4 times and guess correctly? For this kind of thing, it's good to start from the middle. Let's say 50. 55 is greater than 34. Lesser than 47 or 46. It's still lesser than 50. 4 times. Can anyone do this?
Okay,
Wait,
let's try.
I want to ask something. What
What's
is
okay?
What is the chances of guessing right? As in,
The chance is, for example, for you have 1 to 100, the chance of getting right in your first attempt is 1 out of 100.
no.
But when you, for example, when you input 50 for the first time, then you break down the 100 into two halves. Then the chance of guessing right again is 1 to 50 now, like that.
But there's one thing I don't really understand.
What's
Can
that?
you go up? Yeah, this place. when you define the value, you say random dot randint is between 1 and
yes, to choose a random value, just a single random value between 1 and 100.
Yes, I agreed with you. I understand. But the
Okay.
thing, what my question is like, when you predict any number within 1 and 100,
Yes.
based on my own understanding, it shouldn't bring whether it's greater than or less than, provided the number is within.
No, the greater than is for the guess that you input. If your guess is greater than the random number, it will tell you so that you act accordingly.
Oh, yeah,
The
yeah.
guess, your guess is the one that is greater than or lesser than the random. With me myself, I don't know what the random number is,
Okay,
but
yeah,
it
yeah,
will try to it will guide you till you get the correct
yes.
random
Okay,
number.
yeah. I think I understand. Yes.
Alpha Abdullah, you want to guess?
Okay, let's try.
Okay. What are you starting
Now
with?
58.
58. Okay. It's greater than.
Greater than 36.
36. Greater than.
24.
24.
No, let him finish. 20.
24. 54.
24. Is lesser than.
29.
Wait now.
31.
Yes.
You said
31. 31.
correct. Well done. Any
Nice.
other person?
You.
Any other person? For Abdullah Hafiz.
You want me to try?
I thought you wanted to.
43.
43. Okay. Is greater. Your guess is lesser than the random number.
52.
52. It's still lesser than the random number.
61.
61. It's still lesser than the random number.
70.
70. It's lesser than the random number.
88.
88. Oh, I don't know what I typed, but I mistakenly typed something. Sure. Let's start again. Sorry.
51.
51. It's lesser.
62.
62. It's lesser.
78.
78. Is greater.
Then 62, 78, 62, 78. Then I'll go for 69.
69 is greater.
62, 69, 65.
65 is lesser. It's between 66 and 68.
Then it should be 67.
You said so. It's lesser.
Then 68 now.
Definitely 68.
68.
After seven attempts. Is any other person interested? Let me try it one more time. Random number 52 is greater than 35. Still greater. 23 is still greater. Wow. 12 lesser. 20 greater. 19, 17 greater. 15 greater. 13 or 14. 14. That's nine attempts. So the game is somewhat interesting. Then for the second one, there are a lot of people got the answer right. There are some other people that did. Some people, they instead of defining a function, they just wrote like variable BMI is equals to, then they put this inside. So that's not the correct way to do. The correct way is you define the function. This is the function in BMI. Then I said that no need to include any parameter in the function. But if you try to include the parameter, you can do that as well. But once you include the parameter, make sure that you don't define this again, because anything you have here, it will overwrite whatever you have as your parameters. So the weight is in float because we know this thing is always 70 point something kg, something point something kg. Then it's in kilogram, then this one is in weight. This is the formula for BMI. Height squared, like height times height, then you divide weight by the result you get from this. Another thing you can do is to put this, the whole of this in variable. Just call it BMI equals to, then you tell the program to return BMI for you. BMI. This round is just I'm rounding it up to 2 decimal places. So that's what I just broke down what I have in the bracket. So let's go back to what I have initially. So I will try to run this now. If you use a print statement here, you will not be able to use the function here. For example, let's change this one to print. So I will call let me run this, and I will call the function BMI without any parameter, any argument. Then weight, let's say 78.9. Then the height, I don't know, 120. Then that's 0.01 BMI. Then let's try to include it in another function here. Weight 78.9. Then here 120. Oh, we still have our 0.01. Your body, oh, can we see this? Can we see this none?
Yes, we can.
So it is not giving us the return for this BMI, although we have 0.01 here, which is it's prints it out, but it's not giving us the result here. What we need is to include it as part of our print statement. For example, let's say BMI times 2. This is going to give us an error. This is casting. I cannot use it because I have my print statement here instead of return. I have it as part of my print statements now, 0.01. So that's the difference between that's the difference between the print statement and the return statement. So it's always good. It's always good to make use of the return statement instead of the print statement. So I'll try to update the notebook and send it to the GitHub page. If possible, I can work on this mean absolute error before uploading it, or we do it together tomorrow. So this will be the end of class for today. Do you have any question based on the task 3 or based on what we did today?
Actually, my question is what I asked, the question I asked at the beginning of the class.
At the beginning, what's that? Is it for this random number?
Like there are some of this thing I check in Jupyter
Can,
notebook, which is not
are
responding.
you on your system? Can you share your screen? So I know
Yes,
what.
let me do that. Let me do that.
Share your screen.
Okay. Can you see my screen now?
Not yet.
I've started sharing it already.
Okay, you can see it now.
Yeah. See, let me just open this okay. Let me just open a new book. Normally there are some inbuilt what's it called?
Inbuilt function.
Inbuilt function in Jupyter notebook, actually in Python, right? So
yes, the built-in
for
functions.
example, if I want to use print, like this print is an inbuilt function.
Yes.
So normally if I do something like this and I type something like boy, it's normally to bring it out, it will print this for me, right?
Yes.
Now let's now this sum. This is actually where I have issue. Now like this, I want to I said 2, 3, 4. Like this, for example. This is 5, 9. This is supposed to give me 9, right?
Yes.
But if I don't
wait, I know what you're talking about. For example, you are making use of Jupyter Notebook because Jupyter Notebook is very interactive. You get to see the result even without making use of the print statement. If you are using let's say IDE, for example, you are using PyCharm or VS Code. If you type you won't see the result until you put everything in a print statement. I don't know if you understand me. But because Jupyter is interactive, that's why you are seeing the result immediately.
Okay, because if this particular function I type on this screen, I tried it multiple times yesterday. So my thinking is that probably it's not working for Jupyter Notebook. It's only effective on Collabs.
No,
so that was what
everything we have on Collab also works on Jupyter Notebook. Everything.
So it's no, thank you. All right, that's just my question.
I have a question.
Do you have we are done with the class actually? Do you have anyone that has a question or?
Yes, I have a question.
Okay, sir.
Actually, it's about the class today. Like when we did have an array of number that was when we were having like a 2x3 array and we decided to rearrange to give us a 3x2.
Yes.
Now, my question is the order, like when we did the rearrange, like to give us a 3x2,
yes.
I noticed that it did pick like the numbers in order, like probably when we have 3x2. So, sorry, 2x3 rather. It was
Okay. For
picking like the
example,
first numbers.
for example, let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have that's 1 to 9. Let me share my screen. Can you see the screen?
Not yet. Yes, we can see now.
Let's say array np.array. Then we have 1. We have a list, then another list. 1, 2, 3. Then the other one we have. It's actually a function. I don't know why this is not working. np.arrange. Then we put 1 to 9. np.arrange. And stop 1 to 10. Okay, you can see this.
Now, yes.
So if we want to reshape, we need let's say we need 2x3. Let's reshape 2x3. It is not an array yet. We need to make it an array.
Assalamu alaikum. Alaikum salam. Ya kwana biyu. Ya gida.
Please help us mute your mic,
Oh,
please.
sorry. Please, sorry.
Into 2 by 3. Oh, 3 by 3. Let's say 2 by 3, that's 6. Let's say 1 to 6. 1 to 6. 1 to 7 then. Okay, you can see this 1, 2, 3, 4, 5, 6. That's 2 rows by 3 columns. So if you want to make it 3 by 2, 3 rows by, let me name it this one, array 1. Then we have the second one. We are reshaping the first array. Array 2 equals to arr1 dot reshape. This is how the order will be. We have 1, 2, 3, 4. Then for now we'll be having just two columns, this and this. It will be 1, 2, then this will be 3. Then we have 4 here. Then we have our 5 and 6. I don't know if you get, but let me just run it so that you see.
Yeah, actually, my question is it like a kind of how do I say it? Like this is a permanent function, like this is how you take the arrangement.
Yes, by default, that's the default.
By default, yeah, exactly.
It takes in the value one by one, like it's arrange them across the row like this, across the row. The first 1, 2, 3, 4. The same thing when we try to reshape, we have 1, 2. When it's found out that this particular row has been exhausted, it moves to the second row, then continue with the number.
Okay, now I get it. Thanks.
You're welcome. So if you don't have any other question, we can leave the class. This is the end. And the attendance sheet is opened.
Okay, thank you. Bye.